Okay, year 9, I'm going to go over scientific notation we did in class yesterday, just in case there are some students who are away and people who were not able to or didn't understand it fully. Now, scientific notation is just a way of writing really big numbers or really small numbers. And in a moment, I'm going to show you how to use your calculator to do this. But we've got to learn to be able to do it by hand and understand the processes involved. So as you can see here, they give us two examples. So the first example that they give us is this one here. To build the Hoover Dam, there was 3,400,000 cubic metres of concrete. And we don't really want to say that. We'd probably like to say 3.4 times some power of 10, so 10 to the power of 6 cubic metres. The same here. If the mass of a molecule of water is this big number, we don't want to waste all our time writing or saying all of those zeros. There's an easier way to give place value in the magnitude of a number, whether it be magnitude as being very small or magnitude as in being very big. So essentially, scientific notation is just writing. And you need to write this. To write something in scientific notation, you write in scientific notation, you write a number to convert to scientific notation. You write a number between 1 and 10, and I'm going to use the same letter they used. And it's not equal to 10 because if you go 10, you're too big. Between 1 and 10. And then multiplied by a power of 10 to give you the magnitude. Now, as long as you can convert numbers into scientific notation and out of scientific notation to get the number, you're going to be all right. So in class, we go back here. In class, we did these ones. So I'm just getting our work up for the week. And here we go. And there we go. So we're doing scientific notation, and we're doing 6F, 3, 4, 5, 6, 7, 8, 9 last columns. So let's just have a look at a couple of these. Now, let's just deal with the first ones, and I'm just going to do the last column, so you can have a go at these yourself. So the first one, I have 4C, and I've got 16,000 million. I know some people will like to refer this as a billion, but that's not actually true. So it is, they changed it. So all you have to do is imagine that the decimal point is currently here, and we're going to move it until we get a number between 1 and 10. And we just got to count the number of times we move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that becomes 1.6. So we've moved the decimal point, but to retain the magnitude of the number, we're going to write times, and we move the decimal point all the way across there. So it's going to be times 10 to the power of 10. Let's have a look at the next one. Negative 8,800,000. So negative. Now do not get worried about the negative number. So here's the decimal point again. That's where it is. We're going to move it 1, 2, 3, 4, 5, 6. I get my number there. And I'm going to get negative 8.8. And how many did I move it? 1, 2, 3, 4, 5, 6 times 10 to the power of 6. So this is really easy stuff. Well, the last one they've written in words, but that's okay. So I go 21,000. I'll just put that there. And again, my decimal is here, and I go 1, 2, 3, 4. I get my number between 1 and 10, 2.1 times 10 to the power of 4. And you can see how easy it is, or not so much for I. There's similar amounts of digits, but in 4C, I don't want to write all those digits down. It's much easier to just write 1.6 times 10 to the power of 6. So we're talking when we're talking about very big numbers, like we're talking about outer space or distances across galaxies or amounts of certain things that are produced, that's when we're going to use this. So now if I do 5C, now I've got some very small numbers. And don't worry about the negative. And again, so I'm just going to put the negative in. That negative just stays there. It's just a negative number. It makes no difference. Here's my decimal point, and I've got to move it this time the other way to the right. 1, 2, 3. And then I get my number. So it's negative 8.76. And what did I move it? 10 to the power of 3. I moved it 3. But to indicate direction, like I've moved it the other way, I've moved it over here, I have to go negative 3. All right, so that shows me that it's a very small number. So if it has a positive power of 10, it's a very big number. If it has a negative power of 10, it's a very small number. Let's have a go at the next one. And you can see why this is much better to write a number this way. We've got 0 point, how many zeros? 1, 2, 3, 4, 5. I'm going to have to make this bigger. 1, 2, 3, 4, 5, 6, 7, 8. I've got 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I've got 1, 2, 5. And again, I'm just going to move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1.25 times 10 to the power of 10, but because I went the other direction, negative. Now here's an interesting thing that I want you to notice. If I write 0.000 or whatever number, see how many, there are 3 zeros there, and there are 3 in the power. There are 10 zeros there, 10 in the power. So I want you to think now and look at this one. Rather than moving the decimal point, count the number of zeros because there's a 0 before. So I. Hopefully you've already done this now because you've seen how it works. 0.4035. So you don't actually have to go and count the number of zeros. You know there are 4 plus a 1 in front. So I'm just going to write 3.45 times 10 to the power of 5 negative. And now I'm just going to double check by doing my normal step. 1, 2, 3, 4, 5. So it's that easy. And now we've got some mixed up ones in 6. And the first one, 7869.03. Again, I'm just moving the decimal point, but this time the decimal point appears in the number 1, 2, 3. So 7.86903 times 10 to the power of 3. The next one, you might be going, I'm just going to use that trick. There are 3 zeros there. So now I'm just going to write, so that was D, and this is H, and I'm going to write 0.00987. I don't need to do my decimal point jumping. I know it's going to be 9.87. There are 3 zeros there. I'm just going to put, I'm going to write times 10 to the power first. Times 10 to the power of -3. And let's have a look at -128. And that's L, -128. And the decimal point is here, 1, 2. So I get -1.28 times 10 to the power of 2. So scientific notation is pretty easy. Converting. What about going the other way? So let's go with the next one, which is 4.3 times 10 to the power of 8. Is it 7C? 4.3 times 10 to the power of 8. So what I've got to do, I've now got to move the decimal point back. So I've got to go, 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. And where there's an empty space, I have to put zeros. So 4, 3, 1 0, 2 zeros, 3 zeros, 4, 5, 6, 7. Now I'm not going to say the number of zeros is 1 less. It depends how many decimal points are actually in this number. So you've got to be careful with these ones. So we'll look at the next one, which is 9.04 times 10 to the power of 10. So 9.04 times 10 to the power of 10. Now, if you do want a system, the number of decimals in the number are going to take up a spot. So, for example, there's 1 decimal there. It's going to take 1 of those, and I'll have 7 zeros. I've got 2 decimals here, so I'm going to take 2 of those to fill those spaces, and then I'm going to have 8 zeros. Let's just see how it works. So 9.04, I have to move the decimal point, 10, 1, 2, and then I've got another 8. So do I need to draw all the rest of it? No. So I can just write 904, and I'm going to have 8 more spaces, so 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So that's pretty cool. So the next one, 6.357 to the 5 times 10 to the 5. 6.357 times 10 to the 5. Yep. So here we go. So that's going to be 6.357, and that's taken 3 of the decimal places, and I've got 2 more, so 2 zeros. Now, if I'm going the other way, so 8 times 10 to the -10. So 8 times 10 to the -10. There's a really easy way to do this, and I just better get the numbers right. So that was CFI, and this was CFI again. Now, let's go here. I'm going to put my 8 here. And there's the decimal point, and I have to move it 10 the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where the decimal point's going to be. Have it there. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have my 8. Now, here's where there's a lovely little trick you can do with this, and it works every time when you're doing these negatives. If I put a 0 in front of that decimal point, as I really should, I don't want to leave it sort of the decimal point hanging out without anything in front of it. It's all really good to have something in front and behind. I now have 10 zeros, and that will always be the case. The number up there tells you the number of zeros. So let's do the next one. 1.23 times 10 to the negative 7. So I've got 1.23 times 10 to the negative 7. So that means I've got to have 7 zeros. So I'm going to write my first one, the decimal point, another 6, 1, 2, 3, 4, 5, 6, then my digits. And it's that simple. You could go and do like we did here, but it's so much easier just to go, 7 zeros, as long as I include the one before the decimal point. So now I've got 4 times 10 to the negative 1. So 4 times 10 to the negative 1, that's going to equal 0.41. Just 1 0. All right, that should be enough to get you through those questions. If you think you need more practice, try and do some from the other columns. Next lesson, when we do significant figures, I'll incorporate how we use a calculator.